I'm going to play something that changed my whole research direction that led to basically a discovery in physics that will be familiar. All right, thank you. So about 8 years ago when I had a leak here. 8 years ago when I was a postdoc at Stanford, I got stuck. I hit a wall in a project I was working on having to do with quantum gravity, trying to unify quantum mechanics with Einstein's theory of general relativity. And I hit a wall. So what I did was just give up on the physics and went to hang out with my friend David Boyce. Now it's time for this. And here's David. He's a great saxophone player from the Bay Area. I used to hang out with him, and I noticed a book written by Yusuf Lateef, and I opened the book, and this book was filled with a lot of scales, daunting scales, and only one diagram. I'm going to show you this diagram. And at the bottom, it said, birthday present to Yusuf Lateef from John Coltrane. And this immediately struck out as a puzzle that Train left for Yusuf Lateef, who is a great composer as well in his own right. And as I was staring at this thing, it caught my attention. Out emerged a three-dimensional object, okay? And that three-dimensional object reminded me of the very research that I was stuck on in quantum gravity. So today I'm going to tell you a little bit about that. Please bear with me. It took six years to figure this out. That's Yusuf Lateef right there. So I'm going to say a little bit about quantum gravity in a nutshell. Okay. So the first part of quantum gravity is quantum mechanics. The thing I want you to take away about quantum mechanics is that what appears to be continuous, okay, and continuous about matter is actually discrete when we get to atomic levels. So here's a depiction of hydrogen atom, and what we see is an electron jumping, making a quantum leap, okay, in energy, and releasing a packet of energy called a photon. This is basically how a laser works. And the other thing I want you to take away is that the act of observation participates in the outcome. Very strange, matrixy type of take on quantum mechanics. The thing I want you to take away about general relativity is that space and time, actually, and the gravitational force emerges as the warping. So space and time is a fabric that gets warped due to the presence of matter. What we're looking at here is a real picture of something called a proto-galaxy, a baby galaxy, a quasar, that is lensed. A galaxy in front of it lenses the space-time like a kaleidoscope effect and creates 4 copies of the galaxy. It's a very real picture. Space does get warped. And this is what a black hole does to a galaxy like our own, supermassive black hole. So quantum gravity takes both of these things, and it's taken over 75 years for physicists. This is the problem of my generation, trying to crack the code, how to figure out quantum gravity. And the insight is that space-time becomes discrete quanta, just like the atom occurs. And also that space-time becomes atomistic. They have discrete building blocks, just like when you zoom in the New York Times newspaper and you see pixels. Okay? And so after many years of research, my colleagues and I participated in some of this, figured out these are mathematical realizations of the atoms of space-time that tessellate this very structure of space-time that you're interacting through. We call this tetrahedron. Okay? Don't pay attention to the numbers there. So now, I want to go back to giant steps. Think about giant steps now as quantum steps. And I'm going to show you basically how the structure emerges. Okay, how Coltrane's puzzle that I saw was exactly that mathematical realization of quantum gravity. So here we're looking at a circle. I'm now going to paint the circle with notes. These are the circle of fifths. And I'm going to pick the most symmetric object in this, which is this triangle. Each point of that triangle is a note, and I'm going to play that for you. Any guesses? All right. So basically, there's one note in between that, but I played C, E, and A flat there. And if I continue going around this circle with these triangles, I'll get the same pattern. These are the chord changes of the code. These are the Coltrane changes I'm showing you. 4 triangles. If I play these 4 triangles, I come right back to the center of gravity. Now, if I go back to Yusuf Lateef's puzzle, you see that's exactly what Coltrane gave him. Now, if I extend this to 3 dimensions, which is what Coltrane was really after, he kept talking about expansion. He was a big fan of Albert Einstein. Near the end of his life, he was making statements of why is the universe expanding? He wanted to create expansion. If I expand this object out, I have 4 triangles in 3 dimensions, I create the tetrahedra, which is exactly the atom of space and time that we find in quantum gravity. So this is, I took this very seriously, and I ended up in a research project with the director of composition at NYU, Professor Robert Rowe, right down the corner, at Steinhardt. And 4 years later, we figured out how to generalize the structure to all of the 4 notes that what we call tetranotes, chords, okay, in the Western musical system. And this is the answer. This is called the pentahelix. And what it is a reflection of tetrahedra that spiral up into like a helical structure. So it's very interesting that our Western musical scale, geometrically, looks very much like the double helix of DNA. Okay? And now, even in string theory, my colleague, Professor Gates, has applied this to string theory, and you can see that the structure emerges there. So I just want to, I know, it's a bit much. It's a bit much. But these are mathematical realizations of theories of quantum gravity, and it's just intriguing to me and coincidental that fields that at first appeared to be so disparate and unrelated, by bravely and just engaging others in different fields, could lead us to make surprising discoveries and insight, even in our own fields at home. So for the last 2 seconds, I would like to now want you to think about, I'm going to play this again, and I wonder if it's going to sound or look different to you.